Hello, this week we are focusing on functions for grade 8. Our goal is to define, evaluate, compare functions, and use functions to model relationships between quantities. We don't actually need to use function notation in 8th grade yet. So the f of x or f with respect to x, we don't need that part yet. So we're okay with still using y for our function. A function is a rule assigning exactly one output to each input. Does this mapping represent a function? I see that I have a bunch of different inputs that are associated with many different outputs. When I put them in order according to their points, -3, its output is 4, -1 is assigned to 1, 1 is assigned to 6, 3 assigned to 3, 5 assigned to 2, and 7 assigned to 5. I see that each x value, or each input, has exactly one output. Therefore, this is a function. Are these quiz scores a function of the time spent studying? In this mapping, I see, according to my ordered pairs, half hour is assigned to 65, 1 hour is assigned to 70 and 80, 2 is assigned to 97, 2 1/4 is assigned to 90, and 4 is assigned to 75. In this instance, I see that 1 is assigned to both 70 and 80. Since the output of 1 is assigned to more than one output, no, this is not a function. Is the square root of a perfect square number a function of that number? So let's say that the input is the perfect square number, therefore our output will be the square number itself. I see that 1 is assigned to 1, and 1 is also assigned to -1. Further, I see that 4 is assigned to 2, as well as -2. The input of 1 goes to two different output values. This is also true for the inputs of 4, 9, 16, and so forth. Therefore, this relation is not a function. Is the amount paid a function of the number of gallons of gasoline purchased? So the gallons purchased is the input, the amount paid is the output. I see that each input is assigned exactly one output. Therefore, this is a function. Is the growth of bacteria a function of time? So I see time is along the bottom, which is our x values, and the number of bacteria is our y values. So when I make my best guesstimate as far as what these points on the line represent, I see that each input has exactly one output. So this is a function. Is the number of singles sold a function of the amount of time the song stays on the top 40 list? I see that there are more than one output for the input of 2 weeks on the top 40 and for 7 weeks on the top 40. Therefore, this is not a function. Further, we can see that our points are stacked on top of each other as another way to indicate. When a customer calls, you want to be able to retrieve the correct customer information from your database, but something's gone wrong. Sometimes when you input information, the wrong customer profile comes up. What are the possible inputs causing the problem? Create two function options represented in different ways that will help correct your problem. Are there any input-output pairs that correct the problem but may not be very helpful? I see I have a list of first and last names, gender, phone numbers, and customer IDs. Right off the bat, when I look at first names, I see that Steve comes up twice. Therefore, if I'm inputting Steve, I could get Steve Jones or Steve McIntosh. Further, I see that if I were to input the last name of Jones, I could end up with Steve or Mark. So what's probably causing the problem is the first name and last name as our input-output values. Instead, as an input value and output value, I could use the phone numbers. As I look down the phone number column, I see that there are no phone numbers that are the same. Therefore, an output could be a first name. Or I could do a phone number as the input and outputs the customer ID, since each customer ID is unique. However, if I were to use the phone number as the input, obtaining a gender may not be applicable because we don't know who it is associated with. A function defines a relation where each input has exactly one output value. You saw the following advertisement at a local fast food restaurant for a limited time offer on soda. Represent this relation in a way that makes it a function. All size sodas for $1. So let's say I have $1. That dollar could give me an extra large, a medium, and a small. So if I'm using my input as $1, my outputs would be the different sizes. This creates a problem because this does not represent a function, since the only input goes to many different outputs. Rather, let's reverse and have each size represent $1. So now the size is the input, and each input goes to exactly one output. So this is a function. When we identify inputs and outputs as ordered pairs, it helps us to describe the behavior of a function. Jack's ride to school is a function of time. Describe Jack's ride by describing the changing behaviors of the function. Use input-output pairs to highlight important changes in the function. So I've converted my graph here with our points that may be of some interest to us. So when he starts out, I see that it took Jack 6 minutes to travel a half of a mile. Then in 2 minutes, he traveled another half mile, at which point he was traveling at a constant rate for 1 minute. Then it took him 7 minutes to travel 1.4 miles. And then finally, over the last 4 minutes of his journey, he went the remaining 4/10 of a mile. Every year, I receive a summary of my propane gas usage. Describe the usage over the last 11 months. During which month was my usage the highest? How many gallons of propane did I use that month? I can see that I tend to use more gallons of propane in the colder months than in the warmer months. As my graph is decreasing, and then as it gets colder, it starts to increase again. I can see that the highest place that my graph reaches is when it's in January at approximately 1,050 gallons. The table shows the speed of a roller coaster as a function of time. Let's create a graph of this function. Describe how the inputs and the outputs change in relation to each other. I'm going to allow time to represent my x values or my inputs and speed to represent my y values or my outputs. So I'm going to label my graph as such. Then I'm going to plot my points. Once I plot my points, I can see that as time is increasing, the speed also increases until we reach about 40 seconds. Once we reach 40 seconds, we begin to decrease speed until we ultimately stop. I can also see that the entire roller coaster ride is 70 seconds from beginning to end. Travis gets paid by the hour to mow lawns. Describe his weekly earnings as a function of the number of hours he works. If Travis works over 40 hours, the amount he earns doesn't increase anymore. Extend the graph to represent what happens between 40 and 50 hours. Further, next summer, Travis's employer wants to offer him a salary instead of hourly pay. Draw the graph of the function that represents a $300 salary as a function of the number of hours worked. Explain the benefits and the drawbacks of this option. It appears that we have a steady increase of $200 in 30 hours. That would be $6.67 per hour when I take 200 and divide it by 30. Further, there is a greater increase at this point since we go from 30 hours to 40 hours. There is an increase of $125. This is $12.50 an hour. Then it must mean that we must go into overtime after 40 hours. And since we don't earn anything, we will remain at a constant wage from 40 to 50 hours, as indicated here. If we are working a salary, we will have a straight, constant line. No matter where or how many hours that we work, we will always be at 300. The benefits of this is that the more money earned for less time worked. The drawbacks, there's no overtime pay. Your blast explains that in order to make the most profit at the movie theater, the cost of tickets can't be too low or too high. Which profit function correctly represents the profit the movie theater makes as a function of the ticket price? Pause the video and write some ideas down that you have for which one might work the best. I would say the first one. As the price is increasing, slowly the profit is also increasing until it reaches its height or its maximum profit. Then, if we continue to increase the price, our profits go down. Versus the one on the right, as our price increases, our profits go down, and that's not what the statement said, so it cannot be the second option. A boat leaves the dock on shore and rides to a neighboring inlet. After docking for a while, the boat rides back to shore. On the journey back, however, the boat is driving into the wind, so needs to go a little slower. The graph represents a part of the distance the boat has traveled from its home dock as a function of time. Choose the correct description for the last portion of the graph to be filled in based on the given situation. Pause the video and take a gander. The correct answer is letter C. The graph will decrease at a lesser rate than it increased previously because the wind is slowing us down. Let's say two families are leaving the amusement park. Ashley's family has to go 220 miles to home, and Jack's family has to go 180 miles to home. On the right is a function of their time and the distance they travel. What do we know about each trip and which family arrives home first? We can see that Ashley's family, the teal line, traveled home at a constant rate. It also appears that although Jack's family started out at a constant rate, they must have stopped for an hour or so before they began their travels again. Let's imagine extending Ashley's graph. We see that they will arrive home at approximately 3.5 hours after they first began their trip, whereas Jack's family arrives at about 4.5 hours after they began their trip because they had an hour break or an hour stop somewhere in between. When we understand the behavior of different functions, we can compare multiple functions together, such as Ashley's and Jack's family vacation trips. Now let's look at two different bank accounts. Compare the two bank account functions. Which account has less money in the end? Well, I can see in account A that it decreases the more transactions happen, but then starts to it decreases as the more transactions happen, whereas account B increases their balance the more transactions that take place towards the end. Account A has an ending balance of 400 and account B has an ending balance of 325. Therefore, account B has less money in the end.